Okay, so we are now on limits. So what is limits? Limits class describes how a function behaves near a point. Okay? Limit is not the value at that point. Okay? But rather, how does that function behave? But then, limits class is still the y value. What is that y value when we approach the graph of f as we get closer and closer to the point of the graph? Take note, y value. If, for example, you are getting closer, take note class ha, the term that we are using here is closer, which means you are not yet on that point. Take note, near only, but not at that exact point. Let's say our point is, let's say x is equal to 4. Okay, let's say 4. So you are not exactly on the 4, but you are approaching it. You are approaching 4. So what happens to your y? Okay, what is the value of your y as you approach that point? That is limit. Again, limit is what value of y is there if you are approaching that certain point. Okay? So it describes how your function behaves if it is getting near on that point. So to understand this class, what limits are, so let's look as an example here. We have here an f of x is equal to x plus 2. Okay, so that's our given function. F of x is equal to x plus 2. Now, as you can see here, class, here is the graph of your f. Take note, this is graph f, and since this is a linear, so obviously the graph of this function is a line. Okay, now the question is, what is the limit of f at x equals 3? Take note, limit. The question is limit. Earlier, we have defined limit as the value of y value as you approach that point. Now, in this example, what is our point? Our point is x equals 3. Okay, at x equals 3. Now, the question, what is the value of y if your x is approaching 3? Take note. Now, look at the figure. Since we are given the graph already, so it is easy for us to determine the behavior of your function f as you approach 3. Now, take a closer look. Here is your x-axis, right? This is where your x values are. So we are trying to approach 3, but in our function f. So as you can see here, we have here a line. So we can approach this is our 3, this one. Okay, can you see it? This is our 3, and you can approach this from here, or you can approach here, right? So the question is, what is the value of your y? This is your y. You have to focus here. What is the value of y if you are approaching 3? So as we trace the graph, okay, let's approach 3. So this is the 3, right? This is 3. This one, okay? This is this right here. This is the point where your x is equals 3. So as you approach 3 here, what is the value of your y? Can you follow? Can you follow? So as you go, as your x is 3, your y is also going to 5. Can you follow? Or if you go here from the top, your y is approaching positive 5. Do you get my point, class? So therefore, the answer there is the limit is 5. Do you get my point? Simply, class, the limit is again, as you pinpoint the x at that point, let's say as x equals 3. So you have to trace the graph. Good thing about that there is you are given the graph. So you are tracing it. So as I go to the 3, so what is the corresponding y value? That's what you will find out. Y value. Okay? So the answer here, class, is the limit is 5. So based from this, class, ha? So kahit na dito tayo mag-start dito sa sandali. Even if we approach, okay, if we approach 3, this is 3, if we approach 3 from the top, okay, let's say we start at 8 here, or you start here at the bottom, so still your y is approaching 5. Can you follow? So let's say, for example, you are here. Let's say your x is 1. So obviously, your y there is 3, right? The corresponding y is 3. There. So as you go 3, because your target is 3 eh. So as you go 3, your y is also approaching 5. Can you follow? Now as you, let's say you started here at 7. Your x is 7. So you approach 3, so you go back there. While your y, if your x is 7, your y will become, what's the corresponding here? It will be 9, right? So from 9, going to 3, so your y is approaching 5. So I hope, class, that you visualize what I am trying to tell you. Okay? But the question is, ma'am, question, is the limit of f at x equals 3 the same as f of 3? What we meant by that is, the same lang ba yun, ma'am, na pag sinubstitute ko yung x sa equation, so ganun din? Ganun din pagkuha ng limit? Kasi ma'am, kasi di ba yung sabi mo, ma'am, yung limit is 5. Eh di ba pag sinubstitute natin yung 3 dito sa x, sa equation, so 3 plus 2 is also equal to 5. So, ganun din yun ba, ma'am? Okay lang bang ganun yung way to get the limit? Kasi para sa naman sila eh. Diba? And ma'am, diba, we are trying to solve for y. Eh, diba yung f of x is still y, diba yun, ma'am? So, kung isa-substitute ko yung x sa equation, so the same lang yun. So, does that mean, ma'am, that the limit is just the same as substituting 3 to the function? The answer, class, is yes. Okay? Yes. But take note, not always. Oo, pwede mo siyang i-substitute directly in the equation to determine the limit. It's because, class, there are cases where the graph is not given, just like this. In this case, you can easily trace the given value. You don't have to substitute it. You just trace the value of x and then intersect it with the value of y. Then that's it. At that graph. But what if you don't have the given graph? So you can substitute it in the equation directly. But like we have said, yes, but not always. Why not always? Okay, let us have another example. Look at this. Look at this function, g. Okay, earlier we have a function f, right? Now, if you can observe, it is the same. It is the same, class. Take note, ha. Look at this f. Okay? That's the graph of f, x plus 2. Now, look at g. They are the same, right? They are the same. The only difference is that g has a hole at the middle. Take note, there's a hole here. See? But take note the f. It doesn't have a hole on its graph. Now, what's the difference here? Okay? How are we going to get the limit? Now you are asked, let's say the same equation, f of x is equal to x plus g of x is x plus 2, and you are asked, what is the limit of g as it approaches x equals 3? So if we trace it, this is the x, 3. So as we go there, okay, what happens to your y? There. So as you approach from the top, as you approach 3, and as you approach 3 from the bottom, what's the value of your y, or what's your limit? If you can observe, at x equals 3, there is a hole. Now, what can you recall? Can you recall our topic in intervals, where we have used the hollowed hole and the filled hole? Can you still remember that? Where the filled hole represents it is included, but if it is hollow, okay, or an open hole, it means it is not included. Now, in this case, our x, or our value at x equals 3 is hollow. Which means what? Which means, class, that the limit at x equals 3 is undefined. Can you follow? Undefined. It's because it is not included, so we don't know what the value of it at that point. Okay? So that is the case where you can substitute, okay, but not always. So in this case, okay, we cannot define, but what is the limit? But the answer is still 5, class. Can you follow? The answer is still 5. Why? It's because if you are just asking for the limit, kasi 'di ba yung definition ng limit is what happens to your y as you approach closer to that point. Eh 'di ba? Kung makikita natin dito, as you approach 3, your y is also approaching 5. So therefore, nag-a-approach sa 5 pero hindi exactly 5. Can you follow? Kasi nag-a-approach ka eh. Kasi class, pag sinabi kasing limit, class, we are approaching it. We are not exactly at that point. So in this question, ano daw yung limit ng g as you approach 3? Hindi at 3. So hindi yung hinahanap natin is exactly at this hole, but rather what it is approaching. So in this case, as we approach 3, it is also approaching 5. So therefore, the answer is still 5. Can you follow? But if you are asked, pero pag ganito yung question, what is the value? Take note ha, iba yung value sa limit. So pag yung tinanong mo sana sa'yo is value at x equals 3, andyan na yung papasok yung whole. At andyan na papasok si undefined. Can you follow, class? Can you follow the difference of limit and the value? Ha? Yung limit, we are approaching that point. We are approaching that value of x. So what is the value of y that you are approaching also? Do you get my point? As you approach that x, how about your y? What is it approaching? Okay, yan yung limit. Pero pag value, exactly on that point, ano din yung value ng y. Okay? I hope na nakukuha nyo. Class. Now, next is this one. We have another example here. This one. Okay. Let us practice, ha? Let us practice. Okay. Look at the example here. We have h. Okay? Function h. And it has also class? A hole at the middle. But take note, class, that our h here is a function, ha? Y function, because if we make a vertical line test, so it passed. It's because it only goes through one point. So it is, our h here is a function. Now the question is, what is the reasonable estimate? Take note, estimate for the limit. Take note, ha, limit of x equals 3. Okay, so where is your 3 here? This one is your 3. This one. So you can approach this tree from here. You have to trace here, or you can start here. Okay? So you can start here, or at the bottom, or at the top. So if you start at the top, if you approach 3, this one is your 3. What is the value of your y? This is your y. So if you intersect that, it is 2. Okay, it is approaching 2. Can you follow? Also, if you approach 3 from the bottom, from this graph, here going there, it is approaching still 2. Can you follow? So at that point, you are approaching 2. Therefore, the limit of h at x equals 3 is 2. Do you get, class? Do you get what we are trying to do here? Okay. So, it's good thing that we have the graph. So, it's easy for us to see where it is approaching. Okay. So, because of this, class, so we have a special notation. Okay? When we are talking with limits. Kasi napakahaba, no? Napakahaba yung statement ng the limit of the function blah 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 as it approaches blah blah blah. So napakahaba na isulat natin yan. So we will be using special notation, and this is the special notation that we will be using. The limit, or the lim, symbol lim, f of x, x arrow 3. So this is read as the limit. So this expression lim, the limit of, and then your function. So it could be f of x, or it could be g of x, or it could be h of x. So any letter. So in any given function. So in this case, you are given f of x. So the function of f, and then you read this as x approaches 3. Okay, so the arrow there indicates it only approaches, or going to, or getting closer to that value. Okay, so again, this notation is read as the limit of f of x as x approaches 3. Okay, do you get it? So again, that is our notation, class. Sorry, is our notation. Now, let's have another example. Okay, this one. So how do you read this? What is a reasonable estimate for the limit of the function f as x approaches 6? Okay, so we are given here the graph, so it's easy for us to determine the limit. Okay, so if you can observe here, there's also a hollow here. Okay, so where is 6? This is our positive 6. So if we approach x from the top, what is the value of y? It is negative 3. If you trace it from here, if you approach it from the bottom, it is still approaching negative 3. So therefore, class, our answer is negative 3. Can you follow? Simple as that. I hope that nakukuha ninyo. Another. Okay, we have, by the way, this is already example 2, and we have example 3. Okay, our last example. Which expression represents the limit of x squared as x approaches 5? So what we are trying to do here is, how do you write limit of x squared as x approaches 5? So in this case, class, what is our function? Is it 5, x squared, or x? So obviously, our function here is x squared. Can you follow? So we are trying to get the limit of x squared as x approaches 5. So what do you think? Based from these choices, what is the appropriate way on expressing our limit? So obviously, it is this, or this is the answer. Can you follow? So your f of x, if you could recall here, your f of x is your equation. Okay? So not all the time you will write here f of x or g of x whatsoever. So if, for example, you are given the equation, just like for example this one, x plus 2. So instead of f of x, you will write it limit of x plus 2 as x approaches 3. Okay? Instead of f of x. So this is how you will write it, this one. So limit of x squared as x approaches 5. Class, limit is somewhat easy. Easy siya to determine. Okay, so that's all about limits. I hope that you understand how to get it. Again, remember that limit is how, or it just describes how your y behaves or your function behaves as you go near or as you get closer at that certain point.